Our speaker is Dr. Gail Prins. Dr. Prins is the Michael Reese Endowed Professor in the Departments of Urology, Physiology and Biophysics, and Pathology at the University of Illinois at Chicago. She's a full member of the UIC Cancer Center, where she serves as the co-director of the Prostate Cancer Research Program, and she's also the director of the UIC Andrology Laboratory, which diagnoses and treats infertile couples and provides sperm banking services to patients nationwide. She's an internationally acclaimed researcher focusing on prostate cancer development, prostate stem cells, hormonal carcinogenesis, endocrine disrupting chemicals, and the fetal basis of adult prostate disease. She speaks regularly at scientific meetings around the world and has authored more than 170 peer-reviewed manuscripts, as well as book chapters and position papers. And she recently served on the Endocrine Society Task Force that released a 2015 scientific statement on endocrine disrupting chemicals, which she'll speak to us about this morning.
Very thirsty this morning. Thank you very much for that kind introduction. So just, I want to tell you about something that maybe some of you know about already, maybe some of you have never heard about. It's an exciting topic to me. It's somewhat of a scary topic as well, but one that everyone needs to know about, and I feel an obligation to society to inform groups of people like yourselves of the information that we've accumulated as scientists, because it's really got to get out there. You need to know about this. And so as you can see up here, this is, I took this along. I'm going to talk about a group of chemicals, and I'll introduce it to you in a little bit depth as we go forward. But this is how this particular talk came about, and how Sherry found out about me and invited me to speak today is because I'm one of the co-authors on this new statement from the Endocrine Society. So the Endocrine Society is a large body. It started here in the United States, but it's an international society. It's the largest society of medical endocrinologists, PhDs, and MDs. And so we focus on studying, researching, and addressing important medical issues about the endocrine system in our body, our hormones that regulate our homeostasis in our bodies, okay? If you have an endocrine disease, you go to see an endocrinologist, and that person would be a member of the Endocrine Society. So the Endocrine Society became very, very concerned in the past 10 to 15 years about this class of chemicals that's now being recognized as endocrine disrupting chemicals. And to address that, the society formulated or put together a group of scientists. I was one of that at that time, and in 2009 released the Society's first position paper ever, and they chose the Endocrine Society to be, they chose endocrine disrupting chemicals to be that topic. And they released a position paper on endocrine disrupting chemicals, chemicals in the environment that can cause harm, and they do so by disturbing the endocrine system. So this came out in 2009. And this year, at the end, in December of 2015, we came up with a 5-year update. It took us a year and a half to put it all together. Whereas this one was a very thin little accumulation, looking at what's known in the literature, what's known scientifically, not just hearsay, but what's been published on in peer-reviewed papers on this. We updated it to this new large document. It took us a year and a half to put it together. We reviewed thousands of papers that have been written on this topic. We assessed whether they were robust, and if they were, we discussed them and put them in here. And then this is, if anybody wants that, I could just hand it out or give you a link if you want it. This is a summary statement. So I'm just going to talk to you about this issue that we feel is important and needs to get out there on endocrine disrupting chemicals, okay? So we all know that our life is so much better because chemicals are being produced, and they're in products old and new. And here's a list of some, just a little bit. There's literally 80,000 chemicals that have been registered right now in the United States, and this is just a list of the few of them that are out there, and they've known to be particularly harmful at some level. And so we need to be concerned about, as citizens, about our exposure to these chemicals. All right, so what is an endocrine disrupting chemical? So this is the statement from the Endocrine Society. It's an exogenous and external chemical. It's a man-made chemical or a mixture of chemicals that interferes with any aspect of how hormones work in our body, okay? And they mimic hormones, or they block hormones, or they interfere with the way hormones work in our bodies. So some of them are called endocrine mimics as well, or endocrine antagonists, working against the endocrine system. And so this is just a smattering. I got this from the National Institute of Environmental Health Sciences. This is one of the branches of the NIH. And this is just a list of a few of the endocrine disrupting chemicals that are out there. There are herbicides and fungicides and all these different classifications. And the color code system is starting to break down what these chemicals do to different hormone systems in the body. So if they're light blue here, which most of them that we've looked at are, they mimic estrogen activity. And estrogen we always think of as the female hormone that drives our fertility, but we also know that estrogen has a big role in men as well. If they're in red, they block androgens, which is testosterone, the male hormone, which also has a role in females. And usually we have estrogen mimics and androgen antagonists, blocking androgen action. And so these chemicals in nature, out there in our environment, can feminize. They feminize fish, they feminize a lot of lower species, and there's evidence now that they're doing that in humans as well. There's chemicals in green that block thyroid hormone action, which controls our metabolism. And a variety of other processes. So if we break them down, where are these chemicals coming from and what are they used for? And there are a lot of these chemicals in pesticides. That is not to say all pesticides have these actions. Some of them are inert and don't disturb anything. There are chemicals in pesticides that disturb our general well-being, but they don't do it through endocrine action. So there's a lot of chemicals, 80,000 out there, and only a few thousand of them are actually endocrine disrupting chemicals. So they're found in pesticides, herbicides, fungicides, things we spray around the house and use out in the fields, or in flame retardants, you know, all that Scotchgard that's now being removed. The chemicals that are in all the baby wear, they're in industrial byproducts, surface protectors, sunscreens that we slather on our body, plastics, all the plastics that we use every day. Remember that, what movie was it? It's Plastics, my boy. Graduate, yes, it is plastics. Plasticizers, cosmetics. All right, we won't go there, but there's over 1,000 endocrine disrupting chemicals that have been identified now, and undoubtedly more that have not yet been identified as interfering with endocrine action. And so the concept of environmental exposure to these is changing. We used to think of it as chemical exposures happen at the factory or they happen at the farm, where people are spraying really high concentrations of these chemicals around. But this is not really true anymore. Every body has a body burden of toxic chemicals in our body right now. It's in our blood, it's in our urine, it's in our fat, it's in our breast milk that we feed to our babies. Okay? So this is just a little quick example. The CDC, the Center for Disease Control, looked at chemicals in the cord blood from newborns as they were born, and they identified 287 chemicals in cord blood. It's in breast milk, PCBs, dioxins, pesticides, mercury, flame retardants, Of the people tested by the CDC, 93% of them had bisphenol A. That's a compound I've done a lot of work on as it relates to prostate cancer. Phthalates, which is in our medical tubing and other real pliable plastics, they antagonize androgen action. Little babies in the ICU have very high levels of phthalates in their body, just as their sex organs are being determined. There's PCFs, polybromide diethyl ethers, fluorinated compounds, triclosan, that's that little bacteria rub you put on your hands every time you touch somebody, PCBs. These are all in really high concentrations or all detectable in all of us, literally, at any given time. And so we should be concerned. Okay? We also know that chronic diseases are on the rise. Leukemia, brain cancer is increasing, asthma is increasing. We know that there's an increased difficulty in conceiving and maintaining pregnancy, and there's increases in autism diagnoses. And there's a lot of reasons for increases in these diseases. I'm not here to tell you this is from endocrine disrupting chemicals, but we have to ask the question, what are all these chemicals in our environment doing and impacting on our body that might be contributing to this? So there's a lot of hearsay, there's a lot of frantic talk in the press. There's people who say it has it does negative things, people who say it doesn't. That's all a bunch of hogwash. And in this context, the Endocrine Society got together and decided, let's take an intelligent, academic, scientific approach to look at all these chemicals and really determine, is there evidence out there that supports this? And so the topics covered by this new position statement were, I think, let's see, 1, 2, 3, 4, 5, 7, okay? 7 different areas. One person who's a specialist in the area, 1 or 2, really focused on obesity, diabetes, and cardiovascular disease, and that's this new syndrome called Metabolic Syndrome, and that has increased at epidemic proportions across the world. Female reproductive health, male reproductive health, hormone-sensitive cancers in females, prostate cancer, I took care of that, thyroid gland, and neural development in the neuroendocrine system. So the key principles that we came up with that we made in our statement are that endocrine systems are the body's interface with the environment, and they're targets of endocrine disrupting chemicals. And early in life, developmental period is when we're really vulnerable to these chemicals. So the youngins, the fetuses developing in pregnant women. And they don't necessarily present with the disease at birth, but they predispose the body to latent diseases and diseases that develop over the lifetime. The body gets programmed, and we get predisposed to an increased susceptibility to disease later in life. This is the fetal basis of adult disease paradigm. We've defined dose-response characters. We find that these things do occur at really low doses. We don't need doses of factory workers who are making the chemicals. In fact, the endocrine system, if anybody has any medical background, we know that the endocrine system works at femtomolars and picomolars, really small, 10 to the minus 9 to the minus 12 to the minus 15 level. Nanomolar of hormones, really tiny little amounts of these chemicals in our body normally regulates us. So we only need tiny little amounts of these chemicals to interfere with it as well. We're better able to understand how this is happening on a molecular level. Of course, the nature depends upon when we look at it. And now there's accumulating a lot of human studies and epidemiological associations that are tying these compounds to chronic disease. So where did we start? We found that twin studies indicate that the environment plays a key role in many diseases. So twins who are born and then live in 2 different environments, they can develop very differently. So we know it's not just genetics. A lot of what we become is the environment. Environmental and occupational exposures have demonstrated that there are direct associations between chemicals and cancer, metabolic disease, and infertility problems. And so a few of these are in Seveso, Italy, where a dioxin factory had a big explosion and all this dioxin was released in the air. They're following up that population still to this day. That took place about 35 years ago, and there's a lot of increased disease in those people. Agent Orange, that nasty chemical that they sprayed in Vietnam, and they're following up the Vietnam veterans and finding that they have, especially if they were exposed to high levels of Agent Orange, they have a lot of diseases with regards to that exposure. So what does our government do about it? Not a whole lot. There's a Toxic Substances Control Act, which was put into effect, I think, in the mid-'80s. It's very, very weak. It says that we need to have an inventory of the chemicals. So now we do have an inventory of 85,000 chemicals, but very few of them are ever tested. Our modus operandi in this country is make a chemical, put it out there, and use it. And if you can prove to us that it has harmful effects on you guys, we'll reassess whether it should be out there. But there's no, in other parts of the world, it's like you can't put a chemical on a market until you prove that it's safe. Not so with a whole lot of things that we come into daily contact with. So TSCA needs to be updated. All right. So what did we conclude? We conclude that there is more conclusive evidence than ever before regarding how endocrine disrupting chemicals interfere with our bodies and negatively impact health. So this is not hearsay. This is not mumbo jumbo coming out of a bunch of fanatics. This is real. It's academically, medically based, and it's something of true concern. So I'm just going to quick go through this. I know you don't want to hear all this. These slides were put together for a scientific audience, but it just really summarizes all the different chemicals that we could find evidence for, that it is, in fact, driving diabetes, obesity, and cardiovascular disease. And these all interface with each other. You don't need to necessarily be obese to have diabetes. You don't necessarily get diabetes if you're obese. Different chemicals can drive or increase our susceptibility to get these diseases. And so based on your exposure and your experiences, you're going to be predisposed for more of these diseases than if you were never exposed to these chemicals. I guess that's the bottom line. There are chemicals out there now that we refer to as obesogens. These are chemicals that we're taking in that might not directly make us obese, but they make us much more susceptible for weight gain and fat accumulation than if we didn't have these exposures. Female reproductive health, we identified a number of chemicals, bisphenol A, pesticides, persistent organic pollutants that do interfere with fertility. They interfere with the way the ovary releases the eggs, the way those eggs are matured, and it can compromise the fertility. It can lead to many disorders in females like polycystic ovarian syndrome, PCOS, endometriosis and fibroids, which is really reaching very high proportions in women in childbearing years. Preterm birth and adverse health effects have also been linked in scientific studies to these chemicals. Male reproductive health, likewise. There's a syndrome that was defined 20-some years ago, 25, 1990, I remember Skagebeck from Denver coming out with this testicular dysgenesis syndrome, and he was just crucified when he got up and gave these talks talking about this onset of this new disease called testicular dysgenesis syndrome, where testosterone levels were lower, sperm counts were going down. There was a lot more hypospadias occurring in newborns. That's where the urethral opening doesn't open at the end of the penis, but it opens at some misaligned place along the penile shaft. There's a huge epidemic and increase in hypospadias, and the highest area of that in the world right now is in Denmark, a farming society. where they have very high levels of these chemicals. And there's an increasing incidence of testicular cancer, and they've been able to tie this all together with endocrine disrupting chemicals. Hormone-sensitive cancers in females, ovarian cancer, but particularly breast cancer. There's a lot of work about how these chemicals, because they're mimicking hormones. This is a hormone-driven cancer. Endocrine cancer is driven by estradiol. So chemicals that mimic this at the inopportune points in our life can interfere with normal mammary gland development and set the stage for a predisposition to higher rates of cancer in the general population. I also found this looking for prostate cancer. Agent Orange, which contains a lot of dioxin, those men exposed to Agent Orange in Vietnam have a twofold higher incidence of prostate cancer. And we know that prostate cancer is very high incidence disease anyway, but if you've been exposed to some of these chemicals, you do have a higher incidence of getting them. So polychlorinated phenols, bisphenol A, and a lot of other chemicals. And we've been able to show in work in my laboratory that if the exposure occurs in early life, you can reprogram the way the stem cells grow. They do it by not affecting your genetics, but by permanently reprogramming your epigenetics. And then later in life, you're much more susceptible to develop prostate cancer. So there's a lot of gene-environment interactions that have been identified. Thyroid gland, this is really now coming out. People didn't look at it early on, but you know, our thyroid system regulates a lot of hormones in our body, but it really influences neurodevelopment. And now they're starting to believe that by interfering with thyroid development, this may be a mechanism that explains the changes in cognitive deficits in children exposed to these disruptors prenatally. And neurodevelopment, the neuroendocrine system. So Andrea Gore, who's the editor-in-chief of Endocrinology, is a neuroendocrinologist, and she took care of this particular fund. And, you know, the brain regulates, the endocrine system both regulates our hormone release, and it is regulated itself by hormones. So it's very, very sensitive to the endocrine system. This, the neuroendocrine system controls everything. It controls our reproduction, our growth, our responses to stress, and other bodily functions. And endocrine disrupting chemicals exposure can cause sex-specific changes in neural development, and it documents that and human epidemiology data has shown very strong associations between these exposures, particularly early life exposure, and decreased IQ, increased neurodevelopmental problems, and other neurocognitive outcomes. So hyperactivity now has been strongly linked to some of these chemicals, such as bisphenol A. So to just summarize, there's this scientific, this is our conclusion. Right now, we as scientists and endocrinologists believe that we have a consensus that there is a critical and sensitive period during development where exposure to these chemicals can be particularly adverse. It influences reproductive and hormone-sensitive cancers. Endocrine disrupting chemicals have effects on our thyroid system, on our neuroendocrine and neurodevelopmental system, that these effects occur at low doses, and the whole thing of non-monotonic is an interesting thing, but you have to get into, I can answer any questions about that, but I won't do that now. And there's now not a consensus, but there is mounting and growing agreement that it contributes to the metabolic syndrome of obesity, diabetes, and cardiovascular diseases. And we're now performing a lot more large epidemiology studies where this takes thousands and tens of thousands of humans to look at this on a global scale and see if there's a direct connection. And so there's agreement in the community that we really need to be moving in this direction to nail this down. And so we recommended this for research, that we need to have more mechanistic studies, at a variety of level, receptors, enzymes, and importantly, we need to translate all the data that we're getting from our animal models into the human system. We need to evaluate the effects of endocrine disrupting chemicals at different stages and to consider sex and gender differences in our research. We need to look at multi-generational. This is a fascinating new area that's coming out where exposure to a woman or a man, there is paternally transmitted diseases as well, but literally where this is transmitted not just to your child, but to your grandchild, and so on and so forth. And so you can reprogram in the epigenome, and this can permanently shift generations to come. So that's been shown at very high dose exposures to chemicals like the pesticide vinclozolene. Does that occur at lower doses? That hasn't been well documented. Does that occur in humans? That hasn't been shown either, but new evidence with diethylstilbestrol is, that a lot of pregnant women took in the 50s is starting to show that their granddaughters have adverse effects. So there is evidence that this can be transmitted throughout generations, and so that's a scary thought too. And we need to really have team scientists, and we need to work with a whole bunch of people, not just the scientists and the epidemiologists, but we need to inform the healthcare providers, the public health professionals, and we need to inform the public about this. And so what are the recommendations beyond research? We need to educate the public, and that's why I'm here on Super Bowl Sunday. We need to provide this information to the media and the government, and I try to do so every opportunity. I was very involved in getting the Bisphenol A ban in the city of Chicago, which you just have to know Chicago politics to do that. That's not so difficult. But getting it passed in the Republican-controlled committee down in Springfield was next to impossible, so there still isn't a statewide ban. We need to recognize that EDCs are an international problem. This is not confined to the United States. The third world, in fact, is bearing the real brunt of this because we're dumping a lot of our chemicals into the third world. We use those as our garbage pile. Seals and walruses and animals up in the Arctic, if you go and take out their blubber or their serum, they have very high levels of these chemicals, so they're all throughout the world. We need to cultivate the next generation of researchers. We need to make sure that the funding agencies to do this basic research prioritize this research and they work on prevention. The whole issue of how much evidence is enough, I have a little slide that's going to show you, do you wait until there's absolute proof, or do you take the precautionary principle and say, let's hold back on letting these chemicals out there until we know that they're safe, rather than use them until we've absolutely proven that they're unsafe. And we have to evaluate chemicals prior to their introduction into the market. So, this is the precautionary principle. It's an evolution of an ancient medical principle of first do no harm. And the principle implies that there's social responsibility to protect the public from exposure to harm when scientific investigation has found plausible risk. So I put this slide together when I was given a talk on bisphenol A. Bisphenol A is not one of the more toxic chemicals out there, but it's a chemical that a lot of research has been done on. A number of countries have voluntarily phased it out. A number of states and the city of Chicago have reduced or restricted its use in products for children's use. The U.S. FDA, they say there's some concern, but they're run by the industry, and so there's a lot of pushback there. The AMA, the Endocrine Society, the American Society of Obstetrics and Gynecology, a lot of medical societies are coming on saying we have to do something to stop the release of these chemicals into our environment. So I would argue that we should use the precautionary principle to ban or restrict harmful endocrine disrupting chemical usage to reduce its exposure and the resulting long-lasting adverse human health effects. I have a whole bunch more slides if anybody's interested in what can we do about it. I don't want to just leave you down in the dumps. If you'll give me a few more minutes, I'll run them through you. What can we as individuals and citizens do? And there's 5 areas that, and these are slides from the NIEHS. We can prevent exposures at home. We can prevent exposures at work, reduce it in our community, become a smart consumer, and make the government work for you, because after all, they are supposed to be us. I can give you copies of these slides. I'm happy to share them with anybody who wants them. There are a number of things we can try and avoid exposure to. Smoking is obvious. We know that we can get a lot of health benefits by avoiding it, but there's so many other things. Our upholstered furniture, be careful about what that's exposed to. Dry cleaning products, polyvinyl chloride products, those antibacterial soaps, beware. Pesticides, air fresheners that you use at home. Become smart about these and avoid the nasty ones. There's a whole list of things that you can do in your home, but it really boils down to using natural, clean, safe cleaning products with no fragrances, etc., etc. I like the last one. Use borax, red chili pepper, and paprika, and mint to control household pets. Reduce exposures in personal care products. Phthalates, perfume, nail polish, which I'm totally blowing off. Sorry, I've got to have some. So hairspray, there are a number, there's parabens that are in the sun-blocking agents, have estrogenic activity. We slather them on the body of our young ones. And, you know, we do want to prevent skin cancer, but there are alternatives, and we need to look at alternatives. Antibacterial soap, hair dyes, hair straighteners. They have a lot of these chemicals. And you just use a little bit here, a little bit there. They add up and they work together. And there are tips for sunscreens that are more effective. The old zinc, the titanium dioxide, those are all very safe. It's the parabens that we really have to be careful about. The SPF above 50. The sprays and powders, avoid them. Use the creams instead. Put a hat on. Air fresheners. These air fresheners are a huge industry, and they contain a lot of phthalates. And those phthalates block testosterone action, so they contribute to feminization. Learn about your products. Read the labels. Find out what you're using in your everyday life. There are a lot of websites that you can go to and search if you're really concerned about them, and I would suggest you should be. We can reduce our exposures in how we prepare our food when we eat and drink. Avoid those spray stick pans, high fructose corn syrup. Use the water filters in the kitchen, especially if you live up there in Michigan. Avoid polystyrene. French fries have acrylamides in them. They're very bad for you. Not just the fats, the acrylamides. When you grill, don't grill all the way till it's burnt, because that increases chemicals that have very adverse effects. There are a lot of pesticides in fruits and vegetables, so we just want to eat fruits and vegetables, but there's a lot of pesticides in them. There's a list here called the Dirty Dozen, and those are chemical vegetables and fruits that have a lot of chemicals on them, and then there's some very clean ones. I strongly recommend, if you can afford it, to go with organically raised, so that you're not ingesting these chemicals on a daily basis when you eat your vegetables, which are good for you. There are safe choice plastics, and there are plastics that are not safe choice. So you can make a mental note. Ones that, they all have this triangle on the bottom, and that triangle with the number identifies what type of plastic it is. And plastics that are 1, 2, 4, and 5 have been shown to be safe. They don't have endocrine disrupting activity. Plastics that have 3, 6, and 7 should be avoided. That's your polyvinyl chloride, your polystyrene, and your polycarbonate. So you shouldn't be using those to work with your food and beverages and other things that you might be ingesting. So this is a list of ones that are safe and ones that aren't so safe. Polypropylene, I think that's most of what our water comes in. That's okay. You just don't want to store it in those polycarbonate bottles, which release bisphenol A. Reduce exposures in what you wear. They put so many chemicals on what we wear. Try and use clothing that's made of natural, untreated material. Avoid those flame retardants, especially on children. That is all hype, that it reduces, death from fires. Use dry cleaners that don't contain perc. Avoid those fabric softeners. Minimize your use of chlorine bleach. Avoid the fluorescent whiteners. And never use mothballs, Mom. Use cedar or lavender instead. They all contain chemicals. All contain chemicals that have harm. Reduce your exposures in the yard. By avoiding herbicides when you, I was up at my sister's cottage last summer, and what's that chemical that Dow put in? She had a big container of it in her garage, and I freaked out. Your babies are crawling around on this yard, and you're just putting all this chemical right on it and then putting your baby in the middle of it. It's really frightening. Move to organic gardening. Recycle, use electronic equipment without flame retardants, clean with non-toxic products, make sure you have good ventilation, avoid non-stick coated pans, etc. Actions can reduce exposures, and so I love this slide. This slide is about lead in the blood of children, okay? We used to have very high levels of lead in children's blood, and where a lot of this came from was gasoline, lead-containing gasoline, and it went in the air, and we were exposed to it, and people had very high levels. And then in this dotted line over here is when they started out phasing out lead gas. And the blue line is the decline in lead in gasoline over the years, and the red line is the decline in blood levels of lead. And, they've also taken these data and they've overlaid them with crime 15 years later, because high blood levels do result in certain neural pathologies that are more aggressive. And they've really been able to associate fascinating work as to how this can drive crime and harm in our society by having something like lead exposures. So we can do things. We can take actions. We need to work to make our products safe and make them made safely so that the people who work to develop them don't get sick as well. Ultimately, this is going to save us money because sickness is very expensive. And so I'll just close with the end, or is it the beginning, with the statement, we have the sacred right and obligation to ensure that our decision-making is guided by consideration to the welfare and well-being of the 7th generation to come. And I'll take questions.
Thank you for a very informative lecture. I just wanted to clarify, so the consensus is that animal studies demonstrate these various harms, but as to harms to humans, there's, as you indicated, growing agreement, but more research is indicated?
No, that's not exactly what we were trying to say. The work that we looked at that allowed us to make the statements about what we came to agreement on was based on studies that included animal studies, they included cell studies, but they also included human studies. So by looking at that whole totality, we were able to come up with confidence and agreement that we think those particular areas harm has been shown quite definitively. We do need a lot more human studies on a lot more things. That's the hardest thing to come up with because we can't experiment.
Recently, a lot of plastic products have been advertised as being phthalate free, and
Phthalate-free, yes.
Phthalates. And the ones I'm most aware of have been hard plastic products, water bottles and the like. Is it possible to make other types of plastics without
Yeah,
phthalates?
so thank you so much for bringing that up. Green chemistry is there. We can make products that are safe. Unfortunately, most of the alternatives right now aren't, and I want to just address that quickly. And so you see a lot of products that say BPA-free. On the hard plastics are polycarbonate. And so they're all going BPA-free now. And what the chemical industry has done is they've substituted it for BPS, which they just changed one molecule into a different position, and it has the exact same effects when we do studies with BPS as BPA. But the legislation has not come down on BPS, it has just come down on BPA. And the press and all the word is just out for that. And so some of the alternates are not anymore safe. Now, when they say phthalate-free and it's hard, that's kind of misleading because phthalates in plastics make them pliable and soft. So medical tubing, you know, that real soft tubing that's in the hospital, that's phthalates. That's all composed of phthalates. So I'm sure they're phthalate-free, but if they were hard plastics, they've always been phthalate-free. So, but there is a growing area of green chemistry. There are a few universities that actually have a division of green chemistry in their chemistry departments. And it's very possible to make them, to design them in ways that don't interfere with the endocrine system. So it's something that we need to demand.
Could you please reiterate which chemicals are the most carcinogenic for prostate?
Oh, yes. Geez, I did that one. Agent Orange, so this was dioxin. The chemicals in dioxin, a number of the pesticides, a number of the farming pesticides have very high levels of prostate cancer when they look at it. And that's largely coming from the agricultural cohorts here in the United States. The government follows about 100,000 farmers and then matches them up with non-farmers, and their rates of prostate cancer are much, much higher, and they're directly linked to exposures to pesticides. Pesticides, dioxins, geez, I'd have to go back and look at the list. Bisphenol A, my work has shown that it increases our sensitivity to develop prostate cancer. PCBs, polychlorinated biphenyls. So there are a number of chemicals. Pesticides is a big culprit out there that I'm very concerned about. And so that's coming into our food. Atrazine, Illinois has a very high level of atrazine in our water. It's widely used as just a generic chemical. Dow Chemical produces it. And I think the Illinois waterbed is the highest in the country with regards to atrazine. And we sued Dow Chemical. They, in the state of Illinois, they came up with immediately looked at the first round of data coming from the scientists, and they handed out $110 million to pay for some filters in our water filtration plants here in the state of Illinois. Just like that, in a bat of an eyelash, they gave us $110 million because they saw what we were coming out with the data. It's a drop in the bucket. There was an article last week or 2 weeks ago in the New York Times, in the Sunday magazine, on PCOFs in Virginia. Go and look that up, what's in the water there. It's very, very, very frightening, but they're driving cancers.
So recently I bought some cookware for the microwave, and it's silicone.
Yes.
And they claim that it's totally safe.
It is.
Oh, great. Because I really like it.
Yes, that stuff is great. And there are alternatives. We just need to find them.
Thank you so very, very, very much. So, I mean, the chemical, there's money to be made. The cancers, the diseases don't come with little flags that say, I got this because of these chemicals or this radiation. There's tremendous societal pressure to ignore these. How do we change the paradigm? How do we?
You know, I get very dismayed about it, thinking that that's, you know, even just working in a chemical like bisphenol A, it's, and they come after you. I mean, the things I've been called in Forbes magazine because of my research that I published on bisphenol A and prostate cancer. It's like, really? Was that necessary? As if I'm some kook off the wall. So it's really hard. There are really driving forces. I think it's got to come from the government and from pressure with consumers, but we don't know about it. We don't know about it until a group of scientists comes up and looks at it. There's 80,000 chemicals. We've looked at, you know, not even 100 of them for detailed follow-up on what it's doing for harm. How do you go about it? I think we need to have a system in this country where chemicals have to pass a certain sniff test before they can be released and used, rather than the other way around. I think there needs to be reform. There needs to be TSCA reform, the Toxic Substances Control Act, not the opera. And the opera is perfect. We don't need reform there. But TSCA reform, we definitely need to push. We need to push our senators and congressmen. I know the senators from California, Feinstein and Boxer, have been really working on that. And it never gets off the ground. It never gets passed. We need reform. The pushback from the industry and the depth of their money is mind-boggling. It makes the tobacco industry look like kindergarten.
Thank you for your work. I remember we had a lecture here by Samuel Epstein, who I know was at UIC also. So it seems like the university has a wonderful tradition of working on.
We have a school of public
like
health,
this.
so yeah.
Yeah. So my comment is just very briefly, and I realize you may not have heard of this, but a low carbohydrate, high fat diet called the ketogenic diet is now being found to be helpful for cancer. They get up to 80% reduction in glioblastoma tumors. So I just wanted to, also prostate cancer.
Yeah.
So I just wanted to mention that there are books on the ketogenic diet for anybody in the audience who might be interested.
Yeah. I have a little bit concern there because chemicals generally are lipophilic and they accumulate in fat. So a little bit concerned when you say high fat, because that to me is a red light for higher body burden.
Yeah, I have an osmosis water filter, and so what chemicals do they, keep out, and which ones do they not?
Yeah, that's a great question. Hopefully lead, but this list from NIEHS said use a water filter. So it's like, okay, use a water filter. But I don't think it's really, really clear what does come out and what does stay in. I know when I work in the lab and I have to have chemicals out of my water for certain experiments and stuff like that. Osmosis doesn't do it. We have to have double deionized followed by osmosis. So, and that's because we know that osmosis doesn't get all chemicals and pollutants out. So I'd have to be careful, and I can't say with any definition that I know that. One thing that I came about this was a good 10, 12 years ago when I was doing some work on bisphenol A and plastics, and it's all in polycarbonate. So where's bisphenol A? Bisphenol A is the long poly chains of bisphenol A make up polycarbonate plastic. That's what they're made of. And so with repeated heating and washing, some of these molecules will break down and you'll get the little individual compounds, and that's an estrogen. In fact, bisphenol A was produced by the same man who later discovered the pill. When he was looking for an estrogen, BPA did it. And And somewhere in the 50s, some chemists found out that if you made a polymer of them, they made this wonderful compound. It's also used in epoxy, so it lines all of our cans. So every can has that little lining in it that's epoxy, and that contains bisphenol A. And somebody called me up, and they were looking for a new water tank in their town in New Mexico. And all the water tanks are lined with epoxy. And they wanted to know if there was an alternative that I might want to consider. And I said, all the water tanks are lined with epoxy? Did not know that. And as I said this to all my colleagues in the field, none of them knew it either. So towns that are storing all their water in these water tanks are just all sitting in, getting hot, which breaks down bisphenol A. There. All of us have BPA. Every single one of you in this room has bisphenol A in your body. And the goofy thing about BPA is it is cleared out of your body within 6 hours, 6 to 24 hours. And so if you all have it, that means you're all exposed to it all the time.
I just wanted to ask, I bought some new frying pans, and they have the white on the inside. Are those safe?
Geez, I don't cook, so I haven't used a frying pan in the longest time. I haven't shopped for one, so I don't even know what you're talking about. You'd have to look at what that chemical is, and you'd have to Google it and find out if it's a safe chemical or not. That information is available. If you are a concerned consumer, you can go and Google that and look all that stuff up. But a lot of these no-stick liners, a lot of that Scotch Guard, they don't use Scotch Guard anymore. That's really nasty stuff. So, but the lining on those pans, I don't know what they're doing now. Silicone is inert, amazingly. Yeah.
Yeah, thank you. What does the industry do on average to trap and hold, store this residue and all these toxic chemicals that they discard afterwards?
Who does? I think
the industry, the chemical industry, or industry in general. How do they store all this toxicity?
They put them in tanks and ship them to where they're going to be used. Where do they get rid of them afterwards? They dump them. Some stuff is sent to third world countries and dumped. Some is dumped in our backyard.
With regard to, I guess, changing public perception and government perception, has it been beholden to the scientists such as yourself who have been doing the work to bring these up, or are there other groups that we can turn to potentially offer funding or additional help or resources to help drive this into the public perception more?
I think education is key. So you all are learning about this. You're all very intelligent people. You come out on a Sunday morning and hear lectures to become informed and learn about things. The majority of Americans aren't doing this. These disadvantaged communities aren't doing this. They don't know. They're the hardest hit. Really, this needs to go out to education. There are groups like the National Defense Research Fund. There are groups that are working on educating the public. So educating the public is critical. I think pushing for reform at the government level is critical. It's going to be backed by scientific data, but we're doing that. Advocating for research for that area is important, but we're getting that. At National Institute of Environmental Health Sciences focuses on environmental health. So that is being done. I'm not saying don't support science, but that is being done. We need to educate the public, and we need to change the government to the extent that it can be, and the public has to advocate for changes. When we demand something, the industry might respond.
Thank you for a great talk. I noticed you mentioned that the phrase metabolic syndrome is fairly new, and I wondered if you could say when it came about and how it came about and explain more what it is.
Yeah, they don't really know what's the basis of it. There are a lot of different theories, but the maps, I started first seeing it in the 90s, and the maps of the United States that are color-coded. So I'll use obesity, the obesity epidemic. It used to be that you'd see all the states, and there was one state that had the over a certain percentage of people in that state were considered obese. And I don't know if it was Kentucky or Wisconsin, but it was one of those two states stuck out. And then it started spreading. And the South got it first, and then it started spreading northward, then it started spreading westward. And now every single state in the United States has over 30% of the population is obese. And it wasn't that way in the beginning of the 90s. And so you can watch these maps change in talks that I see about it, and you just gasp at how this, so it's a wave, it's an epidemic. And people go, oh, it's high fructose corn syrup, which it may be, contributing to it. It's that we don't do exercise. It's that we eat too much. That doesn't explain a sudden massive increase in this disease. It's connected with diabetes. Diabetes is absolute epidemic proportions. It didn't used to be that way. We didn't have every other person having diabetes. It didn't used to be that way. This peanut allergy stuff, which has nothing to do with metabolic syndrome, but that's another whole thing. When I was a kid, nobody had a peanut allergy. Now everybody's got a peanut allergy. What's going on? These allergens are out there in our environment that weren't there before. So things are being introduced that weren't there before that are driving these responses in our bodies. So, yeah, I would say the mid-90s is when the metabolic syndrome, for the past 20 years, started picking up speed, and it's just swept. The Endocrine Society is so dominated now by diabetes research. They basically now run our society. And they used to be this little group of diabetes researchers. And now it's just massive because so many people have diabetes. What's going on? And people don't know the basis of it. We know maybe how to medically treat it, but what's driving it is unclear. But I would propose that the rising increase in exposure level of chemicals in our environment are contributing to it. Because when we take individual chemicals and put them in our systems, they drive diabetes, they drive obesity. Just think what happens when you get a group of them going together chronically.
I read somewhere recently that there are 70 billion bottles produced for bottled water these days. What particular hazards are there? And people are refilling these bottles and using them a second time. Well, and I understand that's also hazardous.
Yes, so the reusing bottles is good if it's made of a safe product. If it's not made of a safe product like polycarbonate, reusing them just allows them to slowly deteriorate. And as they deteriorate, the chemicals that compose that plastic break down and get into your body. So that's where it's not cool. The plastics, that you see this huge plastic patch, they call it a patch. It's the size of the state of Connecticut that's floating in over by the Midway Islands. Out there, it's just the plastic patch, and it's just unbelievable. But as those plastics break down, they break down in really small microparticles, and then they're inhaled by or taken up by fish, et cetera, et cetera. It works right up the food chain. So we get these nanoparticles of plastics in our body, directly in our body. Not just the original chemical, but literally the nanoparticles of plastics. Yeah, polycarbonate is one of them. There's some plastics that aren't problematic that we know of. But polyethylene products, plastics aren't necessarily harmful that I know of as an endocrine disrupting chemical. But when you fill up the ocean with them, they're going to be problematic.
I wanted to know what are some of the best sources online for if you want to look up a chemical that you're using, because I recently had someone try to suggest to me that everybody should have a filter like you are, but instead of stating something as well researched as this, it led me to a site full of quackery trying to sell a filter.
Exactly.
And I'd rather, if we could just tell us what would be the best place for us to look for that information, that would be great.
Our Stolen Future is a good site. It's a good organization. Our Stolen Future. I don't know if that's .org or .com, but you can get very safe information there. There was one on charts. I would go to any governmental body. I think the NIEHS. So if you go to NIH.gov. And then the institute is NIEHS, Environmental Health Sciences. And they have great web resources for safe chemicals and finding information.
There's also a site, it might be the Environmental Working Group, that actually has a breakdown of the different types of water filters and what types of chemicals they reduce, they filter.
This is householdproducts.nlm.nih.gov. So that's coming out of NIEHS. National Library of Medicine, that is, NLM out of NIH. So household products. Yeah.
I am trying to redeem myself by asking a question this time instead of making a comment like I did last time. Yes. There is a researcher at MIT who's looking closely, I forget her name, at glyphosate, which is, I guess, associated with the genetically modified plants.
Yeah.
And is that something you've looked into
No,
at
that's
all?
not working as an endocrine disruptor, but so that's not something that's part of this, but there is concern for that as well. I think the IARC, the International Research on Cancer, or something like that, IARC, I forget what it stands for, but they just declared significant concern with regards to that product.
Your remarks are very scary. I'm almost...
I'm sorry, but it's what we live in.
Let me ask my question, though.
Finding about nuclear warfare.
Right. It's kind of overwhelming, and it's hard for individuals to know where to start to avoid being poisoned or to advocate more, say, government action or group action on this. My question is this, that industry, the industries that produce these new drugs, and they're coming out thousands every day, I guess, and we associate these new chemicals, these new processes with progress. They're making life better, more comfortable.
We're living longer.
And it's obvious that the people who make money by selling these new products will fund studies that may show the opposite, or will try to lull us into being complacent. My question is that this raises the old, how do you counter the old dilemma of correlation not being causation?
Yeah.
And the fact
I
that
think
you can always show, well, we don't know for sure
right,
that this
and
is the cause.
That's what's used all the time, and we counter that with the precautionary principle. Let's see, and that really is that you don't have to have absolute proof. So, no, close. This computer knows that I was looking at a Surface Pro yesterday, and it's protesting. And that is that we have a social responsibility to protect when we see plausible risk. And so you don't have to have absolute proof. If there's plausible information that's showing harm, it behooves the community to take action. It behooves the industry to find an alternative. There are safe alternatives. And ultimately, for the industry, that's going to be economically more viable because they don't have to remake their product on down the road. If they start out with good design to begin with and make products that are safe and have that research to begin with, they're going to save money in the long run. One of the ways we're going about it is this group in Europe decided to go forward and do a cost analysis of the cost of health care due to environmental exposures to endocrine disrupting chemicals. And so they looked at the diseases that are affected. They came up with realistic expectations of the increase in number of diseases because of endocrine disrupting chemicals, that maybe it increases that disease by 3% and it costs X amount of dollars to treat that disease, and there's this many people who now have it, and blah, blah, blah. They came up with billions of dollars in additional health care costs that are necessary to take care of the illnesses because of these products. And so when the industry comes up and says it costs too much, it's going to be economically non-viable to switch this, it's going to be detrimental to the economy, we can turn around and say, no, it's detrimental to the economy if you don't get rid of this. That's the argument that we have to use.
Here's a question. I'm hopeful that there are a lot of studies happening on trying to figure out the effect of chemicals on our bodies. And one question is, I'm not a scientist, and I was a little overwhelmed with all the terminology. And my suspicion is that other people also get overwhelmed when they're trying to figure out what's good, what's bad.
Yeah.
Is there some kind of simplification? Some kind of easy way for average person who doesn't have medical degree or chemical degree?
Maybe I shouldn't have done the endocrine disrupting statement by the Endocrine Society and done a more generic talk. But is there a way? No, because it's not simple. It's very complicated. There are products that are good, there are products that are bad. There are fruits and vegetables that have just so much pesticide on it, so they're the good ones. And then there's the toxic 12, apples. Apples, try and find a good apple. 98% of the apples have pesticides in them. So, yeah, it's not simple. You think an apple is healthy, you peel it. Eat bananas, although they're all genetically modified. Every banana is genetically modified.
So I'm going to go the opposite way. Before my first time I asked a question, and now I'm going to make a statement. I just wanted to quickly say that 4 or 5 years ago, I switched to an organic lawn service. And if you, do your own lawn and you don't have a service, you can purchase the same things that they use.
Thank you.
And my lawn looks fine. And I have read that suburban area is much, much more toxic than any farm. Much worse. Right where you live, if you're in a suburban area and everyone is putting all these chemicals into their lawn, it's like way worse than
terrible.
A farm.
And then they put their kids on the lawn. So let them, they're great, it's outside.
It's the one I use is called Greenwise. Greenwise, one word.
But, that's what we need to do. We need to use pesticides. So I just, what is that product? I just went to one of these house show things. I hate them, but I did it electronically, and it was about these products, these fiber cloths that you can use, and you can clean your house without using any chemicals. My toilet cleaner now is all chemical-free. There are a lot of chemical-free solutions. We didn't have all these 50 years ago, and our houses were clean. And those soaps with triclosan, you should see what happens to eggs exposed to them. So the way we found out about triclosan was one of my colleagues working at Washington State University. She moved to Washington State from Wisconsin, from Madison. And when she moved her animals over there, they didn't get pregnant. She had these huge fertility problems in her animals. She couldn't figure that out. She couldn't get her studies going, and she didn't know what was going on. So she researched out and found out that they used chemical products in cleaning the animal facility at Washington State that they didn't use in Wisconsin, and they contained triclosan. And they were causing chromosomal abnormalities in the eggs. And so those animals were getting pregnant, but they immediately aborted. And this was at usage levels in the animal facility where the floors and the cages were being washed with this chemical. And she was like, crap, you know? So now here's a new chemical out there. That's how she came upon it. So now there's a lot of work being done on it, but she stumbled. I think, you know, I don't know how the people in Washington State got their animals mated before, but it was the shift from her particular line of animals that she was taking with her that couldn't adapt.
Well, thank you very much for a very informative talk.